Question 14 is about the heating circuit for a hairdryer. The diagram shows that you've got two heating elements, R1 and R2. It's possible for them both to be disconnected, or for one of them to be connected, or the other to be connected, or both to be connected. Which is actually what you have on a real hairdryer. Though instead of being separate switches, it's actually got one switch with three positions. So in this position, no elements are connected. Middle position, one element is connected. Top position, both elements are connected. You might also be wondering what sort of Sado has his hairdryer pack tested. Now the question is really about resistivity. And the first thing we're asked, it says show that the resistance of R1 is about 190 ohms. Now when it says show that it's about 190 ohms, you don't use 190 ohms in your working out. What it means is calculate the resistance of R1. So use the data to calculate R1, and then you get an answer, and you know that the answer has got to be about 190 ohms. So you go back to the question as if the question had just said, find the resistance of R1. So how do we find resistance? Well, it's all to do with resistivity. And the formula on the data sheet gives the formula for calculating resistivity. Resistivity equals RA over L. You don't need to find resistivity because you're told it. You need to find resistance. So you've got to rearrange the equation to get resistance. So hopefully you've done that yourself. And you're just checking by looking at the video to get that resistance equals rho L over A. And that's actually the form of the equation I remember. I don't remember the top one at all. That's the way I remember it, because it makes sense to me. But you don't need to remember either of them because it's on the data sheet. So you're told the resistivity of the material, you're told the cross-sectional area of the wire, you're told the length, so you're able to calculate the value of R1. And hopefully you're going to get something that's close to 190 ohms, and so you can say, once you've got the answer, therefore R1 is approximately 190 ohms. Part B, calculate the power output from the heating circuit with only R1 switched on when it's connected to a 240 volt supply. So you know you've got various formulas for finding power. P equals V times I, P equals I squared R, and P equals V squared over R. And since you've just worked out R, and you're told the value of V, it does seem as if P equals V squared over R is the one you're going to use. So if you use the equation P equals V squared over R, you should be able to work out the power output of the heater circuit. For part C, it says when both elements are switched on, the total power output is 3 times the output with just R1 on. So from that you should be able to work out that the power in R2 must be double the power in R1. Because when you add R2 to the circuit, you get 3 times the power. So if you've just worked out what the power is in R1, you know that the power in R2 is going to be double that. And you know that the voltage is the same because they're in parallel. So you now know the power for R2, you know the voltage for R2, so you're able to calculate the resistance for R2. And when you know the resistance for R2, you're able to use this formula, rearrange it to find the length. So you can go through lots of stages of using lots of equations. Alternatively, you could spot a shortcut that means you actually need to use very few formulas and do very few calculations and actually end up with one calculation which you can do in your head. Because if we look at this formula, if R2 has got twice the power that R1's got, then since the voltage is the same, we should be able to spot straight away how the resistance of R2 must compare with R1. And when we know what the resistance of R2 is, we'll go back to this formula. Resistivity and area are the same. If we know how the resistance of R2 compares with the resistance of R1, we should be able to tell at a glance how the length of R2 compares with the length of R1. So in fact, you don't really need to do much calculation at all if you can sort of just think through in terms of the ratios of things. But if you can't think through in terms of the ratios, then by all means put the numbers into the formulas and you should get the right answer in the end. The last part, calculate the total current with both elements switched on. Well, there's various ways of doing it. You know the resistance of R1, and you may have found the resistance of R2, so you can either find the current in them separately, or you could say they're in parallel and find the total resistance and then find the current for the whole lot. Or you could say you don't want to mess about with resistance. You could say that you know the total power in the circuit. And if you know the total power and you know the voltage for the whole circuit, it's very easy to find the current. So there's lots and lots of different ways that will all give the same answer.